Star formation and tidal interactions. The relationship between the Milky Way and its satellite galaxies isn't just a one-sided gravitational pull. It's a dynamic interaction that can spark some spectacular events. When the gravity of the Milky Way tugs on a smaller satellite galaxy, it creates tidal forces that can compress gas and dust within the satellite. This compression can ignite bursts of star formation, leading to new generations of stars lighting up the galaxy. It's like a cosmic trigger for stellar creation. A great example of this is the large Magellanic Cloud, one of the Milky Way's most prominent satellite galaxies. Its close gravitational interaction with the small Magellanic Cloud in the Milky Way has stirred up its internal gas, creating regions like the Tarantula Nebula. This nebula is a star-forming powerhouse, producing some of the most massive and luminous stars in the universe. These tidal interactions are responsible for transforming otherwise quiet galaxies into vibrant star-filled regions. The effects of tidal interactions aren't limited to the satellite galaxies themselves. The Milky Way also feels the impact as streams of gas and stars pulled from the smaller galaxies feed its outer regions. This influx of material can fuel star formation in the Milky Way, especially in its outer halo. These tidal streams act as bridges, connecting the satellite galaxies to their massive host while enriching both with fresh material for future generations of stars. These gravitational dances are more than just beautiful. They provide essential insights into how galaxies evolve and sustain themselves over billions of years. They show that even smaller galaxies play a significant role in shaping the larger cosmic structures around them. By studying these interactions, astronomers uncover the delicate balance of forces that drive star formation and maintain the dynamic nature of galaxies like the Milky Way.